Hello, today we are going to continue looking at factoring and looking at the most difficult factoring situation we're going to look at this year, which is factoring trinomials, things that have three terms, but also the GCF that can be factored out first. Other than having just one extra step at the beginning, this isn't any more difficult than what we did in our last lessons. Also, this is, like I said, as difficult as it will get for this year, and it combines things we've already done. So kind of a new spin on things we've done before. All the trinomials you see here today have a GCF. Factoring out the GCF first not only helps you simplify this as much as possible, but it makes the numbers you're working with a lot smaller. Notice there is a 3-digit number here on your assignment, on your quiz. It will always be numbers that are 100 or smaller. I just accidentally stuck this one in here, but once you figure out the GCF, it's a lot easier. So let's dive right in. The first thing we're going to do is factor out the GCF. So what is the biggest number or variable I can divide all of these things by? Notice I can't divide by a k because there's no k here in this last term, so my GCF is just going to be a number. The biggest number I can divide 2, 8, and 24 all by is 2. So I'm going to start by factoring that 2 out. So 2 will go in front of the set of parentheses. 2k squared divided by 2 is k squared. 8k divided by 2 is 4k. Negative 24 divided by 2 is negative 12. This GCF2 is going to hang along for the ride and stay on the outside for the rest of the problem, so don't forget it's there. But from here, we know that when we see things like this with 3 terms, we start by multiplying a times c together. We're going to use the new a, b, and c that are here on the inside. So a times c here is going to be 1 times negative 12, which is negative 12. So we're looking for numbers that multiply together to a times c, add together to our b number, which now is 4. So if you think about the ways you can get to 12 by multiplying, we can do 1 times 12, 2 times 6, or 3 times 4. Since it needs to be a negative 12, one number in the pair will be positive and one number in the pair will be negative. So the only way we can get that positive 4 is if I use negative 2 and positive 6. Just like before, I'm now going to rewrite the stuff on the inside of the parentheses with negative 2k plus 6k instead of the 4k. So keep the GCF2 in front. I'm going to rewrite this as k squared minus 2k plus 6k, and then the minus 12 stays the same, just like before. Now from here, we know that we factor this by grouping. So once again, keep the GCF2 in front. GCF of the first half here is just k. When I divide by k, I get k minus 2. GCF of the second half, GCF of 6 and 12 is 6. It's going to be a positive since it's a plus sign here. So plus 6. When I divide by 6, I get k minus 2. So I know there's like a lot of parentheses right here. Don't let that scare you. I need these outer parentheses to show that I'm undistributed the 2. I factored out the GCF2. These inside parentheses are to represent when I'm factoring by grouping. At this point, I've done all of the hard work. I just need to regroup and make my final answer look pretty. So my final answer, GCF2 stays in front, and then we regroup this just like we did before. K times k minus 2 plus 6 times k minus 2 is the same as the 2 GCFs, k plus 6 times the repeated factor k minus 2. This right here is your final answer. So it really combines everything we've done with factoring. Like I said, this is as complicated as it's going to get, so not too bad. We'll try a few more. Like I said, on your homework, you're not going to have any bigger numbers than 100. I threw this one in here just to kind of give some practice with one bigger number. So once again, our GCF is only going to be a number because there's no variable in this last term. So I'm thinking, what's the biggest number I can divide 6, 24, and 126 by? If you're ever stuck, always start with the smallest number and see if that's something you can divide them all by, and then work your way bigger if you can. So spoiler alert, if you're still thinking about it, GCF here is going to be 6. That is the biggest number I can divide 6, 24, and 126 all by. So I'm going to factor out that GCF When I divide by 6, I get p squared plus 4p, and then minus 21, because 126 divided by 6 is 21. Okay, so then now we're going to keep that GCF 6 on the outside like we did before. We are going to use the new a, b, and c to factor the inside. A times c in this problem is going to be 1 times negative 21, which is negative 21. So I'm looking for two numbers that multiply to negative 21, but add up to my b number, which is 4. So if we think of how we can get to 21 by multiplying, we can do 1 and 21, we can do 3 and 7, and that's it. So the only way I can get a 4 out of that and a negative 21 if I multiply them is if I do negative 3 and positive 7. So now, leave the GCF in front, rewrite this as 4 terms, p squared minus 3p plus 7p minus 21. Now we do our factoring by grouping. GCF 6 hangs out in front. The GCF of the first half is just p. When I divide by p, I get p minus 3. GCF of the second half is 7. It'll be positive because we have a plus sign here. When I divide by positive 7, I get p minus 3. These match, which is good. That's exactly what I needed. So now I just regroup my final answer. Final answer is that GCF we factored out at the beginning, 6. Oops, did not mean to do that. One set of parentheses is p plus 7. The other set of parentheses is the repeated factor, p minus 3. Order here, like in the past, is not super important. Do typically write GCF in front just because we tend to put coefficients in front. But you could have p minus 3 and then p plus 7, and that would still mean the same thing, not a problem at all. Let's try 2 more. So this time, what is the GCF of 20k squared, 12k, and negative 32? Once again, will be just a number because there's no variable here. The biggest number I can divide all of those by, you might think 2, but we want the greatest one, the biggest one, which is actually 4. So when I divide by 4, I get 5k squared plus 3k minus 8. Now I label my new a, b, and c. A times c is 5 times negative 8, which is negative 40. So I'm going to be looking for two numbers that multiply to negative 40, but add to my b number, which is 3. Thinking of how we can get to 40 by multiplying, I can do 1 times 40, 2 times 20, 4 times 10, 5 times 8, and that's it. In order to get a negative 40, I need one of those to be positive and one of those to be negative. And so the only way I can get those to add up to 3 would be if I have a negative 5 and a positive 8. So now let's rewrite this. GCF 4 stays in front. Becomes 5k squared minus 5k plus 8k minus 8. Now let's do our factoring by grouping. So again, GCF 4 stays in front. GCF of the first half is 5k. When I divide by 5k, I get k minus 1, because 5k divided by 5k is 1. Cancels out. Second half, GCF here is 8. It'll be positive because we have a plus sign here. So plus 8. When I divide, I get k minus 1. These match, so we're good to go. We just need to write our final answer. Final answer will be that GCF 4 we factored out at the beginning. These two GCFs, 5k plus 8, and then our repeated factor, k minus 1. And that's it. The very last one, same process, nothing too crazy here. The only thing that's a little different in this particular problem is this term has a variable in it. All 3 terms has a variable in it, so our GCF will also have a variable. Biggest number I can divide 9, 51, and 30 by is 3. And then the biggest factor of k the biggest factor of k I can divide all those by is just regular k. The only one I can divide all 3 of those by is regular k. So 3k is my GCF, it goes in front. When I divide, I get 3k squared plus 17k plus 10. Just 10 here because the k's cancel for that very last term. So now, a is 3, b is 17, c is 10. That means that a times c is 3 times 10, which is 30. So I'm looking for numbers that multiply to 30, but add up to my b number, which is 17. To get to 30 by multiplying, I can do 1 times 30, 2 times 15, 3 times 10, or 5 times 6. Everything here is positive, so I'm looking for two positive numbers. So the only way I can get to that 17 is if I do positive 2 and positive 15. So 3k GCF stays in front. I'm going to rewrite this as 3k squared plus 2k plus 15k plus 10. Factor by grouping. So again, 3k GCF stays in front. The biggest number I can divide 3 and 2 by is 1. You can write the 1 if you want to, you don't have to. The biggest power of k I can take out of both of those is k. So I can write this as 1k or k. I'm going to write it as just k. When I divide by k, I get 3k plus 2. For the second half, my GCF is 5. When I divide by 5, I get 3k plus 2. These match, so we're golden. We just need to rearrange our final answer and make it pretty. So our final answer will be 3k GCF in front, k plus 5 in one set of parentheses, and a repeated 3k plus 2 in the other. So that is it. About as crazy as it gets. The only other thing we're going to do for this unit is add on solving. So what happens if we have an equal 0 at the end, which is just a tiny bit more work from here. Another friendly reminder is that if you switch, let's just use this problem as an example. If I did 15k first here and then 2k instead of 2k plus 15k, it's going to change what your work looks like a little bit in the middle, but your final answer should be the same. That is it for today. Have a fantastic day.